My name is Hank Held, H-E-L-D, and I'm the CEO of Mount Princeton Geothermal, which is a geothermal development company based here in Colorado, and we're centralizing our operations on 2 locations in Chaffee County, which are in the central mountains of Colorado. What we've systematically done is to isolate the geothermal locations in Colorado that have the highest heat potential. And it's interesting that the highest surface manifestations, the water coming to the surface, is right there at Mount Princeton. But I had to learn a whole new science in the fact that the hottest water is right there does not necessarily mean that's where the hottest resource or reservoir is. And in some of the work that we've done, we actually found that the location where we anticipate drilling is about a mile and a half away from that. And we only found that out after some extensive new testing with a technique called magnetotelluric, which has the ability to actually look 10 kilometers down into the ground and begin to show us the formations of the reservoir that deep. Well, we'd laughed, and when I used the redheaded stepchild, it's simply that wind and solar, I think, are maybe sexier than geothermal. We're just talking about rocks in the ground and water, whereas those are much more visible, and it's easy to say that you can develop the wind and the solar power. But in our case, it's simply that there's so much heat underground that can be turned into electrical energy that it is truly, I think, the best of all the renewables, and we laughingly refer to it as a redheaded stepchild of renewable energy, because it is kind of one that's forgotten, but it's there and it's developing. And one of the distinguishing factors that I spoke of yesterday was that there are 2 revenue stream components to geothermal. The first being that we can bring the water to the surface temporarily, just long enough to turn a turbine to create electricity. But there's a second revenue stream, or potential revenue stream, there in the hot water itself. And we call that the cascading effect, whereas we take that water as it comes to the ground, turn it through the turbine, but then begin to start using it for different applications. And that would be such things as drying fruit, processing actually the lithium that is suspended in the hot water. Some of the other metals, silica is another mineral that can be derived from that. But as it goes down in decreasing heat, there are a number of uses that can be used, and that revenue stream is totally unregulated in Colorado. There is a law called, I believe, the Geothermal Producers Act, which exempts it from any of the Public Utility Commission rate structures. So we are able, as we develop that second stream of income, to basically bill it out to end users on a BTU basis, which is kind of a simple method. And it's that second revenue stream which we think that properly utilized actually makes geothermal more potentially profitable than either solar or wind, even with their current cost curves that are declining in terms of the actual cost of the material being used. Electricity is a fungible item. It's kind of like water. You drill water one place, you put it in the river, and you allow someone to take it out down below. And electricity is much the same. So our basic business model is to identify these hot geothermal locations that are in close proximity to the existing tri-state transmission lines. And I say tri-state because it's largely unregulated. It's a group of 44 co-ops that band together to develop new technologies such as geothermal. And the important thing for us, and one of the key elements in our cost structure, is that we will be able to utilize the existing distribution and transmission lines associated with the tri-state grid. And the important thing here is they currently have excess capacity, meaning that we do not have to put in a lot of expensive transmission lines, that we can utilize what's there and presently being underutilized. That is a big cost factor in our overall calculation. Right now, what we're looking for are the so-called risk capital. We're ready to drill, and it's during this, as we call, a valley of death, which is the highest risk. And once that is defined and we have an idea the size of the reservoir, the temperature, and how much water flow, then it's very easy to attract either financing or individuals like U.S. Geothermal that want to buy projects like that have been so-called proven with the reservoir all mapped out. Generally speaking, what we'll do is go in with the property owners on a royalty type basis so that they participate both in the actual royalties for the sale of electricity plus a rental for the land on which we would build the plant itself, which are very small. It's a very small footprint. Most of the pictures you've seen are kind of obtrusive and noisy, by the way, but they're largely located out in the desert somewhere in Arizona or possibly Nevada, in which case there's no real premium put on camouflaging or hiding the facilities, whereas there's existing technology now, and we feel comfortable we can basically eliminate the concerns of the sight line, the noise, and things like this. And the overall footprint for the plants that we're looking at are relatively small. And by this, I would use a benchmark of a 10 megawatt geothermal power plant, which would take about 5 acres of land, including all the piping and the parking and buildings and things like this. And to give you an idea, 10 megawatt would be enough for about 9,000 homes. And that would basically include the entire 3-county area that Sangre de Cristo Rural Electric supplies. So we could do that all from one location, clean, 24 hours a day. We have our own website at mountprincetongeothermal.com, and I'm available on my cell phone at 303-748-0001.